All right, just logging on, and we are live on Instagram and on Facebook. And today we're talking about friction. And here's what you'll need. You're going to need one clean and empty plastic bottle. You might be able to use a cup, a small cup, a small plastic bottle. I'm thinking like 16 ounces, 12 ounces, something like that, less than 20 ounces. You'll also need about a cup of rice, and you'll need a chopstick or a pencil, some kind of long, thin object, okay, like a pencil or a chopstick. Chopsticks probably will work best. If you don't have them, I get that. So you can just follow along as I do it today. But again, you'll need one clean, empty container. I'm using a plastic bottle. I think cups should be fine, but it'll be a matter of how you pack the rice. We're going to take rice and put it in the container. So you're going to need enough rice to fill the container or come close to filling the container. That's why you don't want to use a really, really big one. But then also, you'll need a pencil or a chopstick. And so I see people signing on. So I'll give everyone a couple more minutes. We'll get started in about a minute and a half. I just want to let people get the opportunity to sign on and to see what you need for today. See, the Wilsons are in the house. I see we got the Stargels in the house. See, we got Lester in the house. On Instagram, I see you over there. Good to see everyone. All right, we'll go ahead and get started. Again, for those who are just signing on, we're talking about friction today, and you'll need an empty container like a plastic bottle. Think like a 12, 16, or a 20 ounce soda bottle. If you don't have a bottle, I think a cup will work, but try to find a cup that is pretty straight up and down in terms of the walls of the container. Hey, Alyssa, I see you. How you doing? Been meaning to call you just to say hi. All right, a cup of rice, and you'll need like a pencil or a chopstick. For example, I have a chopstick here because I like Chinese food. I go to the Chinese restaurant and I get chopsticks. So today we're talking about friction. So what is friction? And I know we got some youngsters out there, so I'll spell the word friction out for you. By the way, do you have your lab notebook? Do you have your lab notebook? Remember, it's very important to have your lab notebook. I've got mine, and I never, ever do my experiments without having written in my lab notebook, all right? So today we're talking about friction. That's your topic. You can write that in your notebook. I'm spelling it out for you. Hopefully you can see it. And I hope my handwriting is legible. So that's friction. F-R-I-C-T-I-O-N. Friction. Friction. Okay, so what is friction? What is friction? Well, friction in the simplest terms is the force that opposes the movement of one object against another. Right? The force that opposes the movement of one object against another. And believe it or not, we've actually dealt with friction before, and I'll explain that in a moment. But in physics terms, friction is what we call a non-conservative, non-fundamental force. all right, is a non-conservative, non-fundamental force. Now, I know those are large words, and I wanted to make sure to use them because I didn't want any of my physics friends to be offended at my definition of friction. But friction is a force that we encounter every day. Every day. How do we encounter it? Believe it or not, friction actually helps us walk. Okay? The ability to move on the ground is aided by friction. For example, if we had a surface, let's say the surface was ice. Most of us have experienced what ice does. I'm originally from Michigan. I have plenty of experience dealing with ice, and many of us have met the ice time and time again, right? Well, that's because ice has a very small amount of friction that you can build up on the surface. But believe it or not, you can still feel the ice, and there is some friction there. But if you can think of ice as being a frictionless surface, then you understand friction is necessary in order to walk. Walking on ice is difficult because the ability to build up a lot of friction is limited. All right, so friction is a very important force, although we often don't think about it. Now, I apologize, there's a little one over here making noise. So pay no attention to the little one crying in the background. The friction, we've used it before. Do you remember when? Go back, I think, about 8 lessons now. Remember, we were taking a balloon, and I took the balloon and I rubbed it on my shirt, and then I held that same balloon next to a soda can, and it moved the soda can. And the reason it moved was because the balloon had static electricity built up. All right, and the static electricity caused the charges in the balloon to align and the charges in the can to align, and that allowed me to move the can. We also moved a stream of water because water is polar, and some of the charged character of the water molecules caused it to be attracted to the balloon on which the static electricity had been built up. All right, but even though we were using static electricity, we built that static electricity by the friction of the balloon against my shirt. Okay, so we have dealt with friction before, but friction is often a small force, a minor interaction on a daily basis. We don't really think of friction as being particularly strong. However, you can build up friction. And in fact, you can build up friction enough of it such that it can actually be very strong, or reasonably strong at least. Okay? So I've gone all this time and I haven't asked the same fundamental question that I typically ask, and that is, what do I need to do in order to be safe while doing what I'm going to do today? Now you saw we have rice, we're using a plastic bottle, and we'll have a pencil or a chopstick. Do I need goggles, eye protection? Do I need gloves to cover my hands? Do I need a lab coat? I'll just tell you that today we don't need any of those items, but you do always want to think about them. All righty, let us get into the experiment. So what are we going to do? I've actually done this ahead of time. I have a bottle here. This is a 16-ounce plastic bottle, and I've taken rice, and hopefully you can see it's almost full to the top. It's full to just below the mouth of the container. And in the bottle, I have my rice, and I've packed the rice in there fairly tightly. Okay? Pack my rice in there fairly tightly. So I'll give you a moment to do that at home if you are following along. By the way, again, if you're using a bottle like this, make sure it's very clean, because after this is over with, you can, of course, retrieve your rice. Okay? And I don't want you wasting rice, especially in these times. I love rice, by the way. It is one of my favorite foods. So please don't waste your rice. It's valuable. Well, you want to pack the rice in there pretty tightly. One way you could pack the rice in there is by, once it's in your container, tapping the side. You can tap it with your hand. You can tap it with a knife or something like that. And make sure it settles further down into the container. And what you'll find is often when you do that, there's a lot more space at the top. You could add a little more rice to fill it back up and then pack it in there some more. All right. Now, what I want to do is find out, normally when I eat rice with chopsticks, and my chopstick skills are okay, I'm not very proficient, but I'm okay. I can get by. Well, when I eat with chopsticks, I normally pick up my rice and all my food using 2 chopsticks. Here's your question for today. Is it possible for me to pick up all this rice with just 1 chopstick? What do you think? What's your hypothesis? Make sure you write it down. Now, again, what is a hypothesis? What is a hypothesis? A hypothesis is an idea, a prediction, perhaps a guess that you can test. Okay, it needs to be testable. A hypothesis has to be testable, something that I can control certain aspects of my experiment so I can look at one specific variable. Okay, so a hypothesis needs to be testable. That is the distinction between just a guess. All right, so what is your hypothesis? Because we can test it, and we're going to find out today if it is possible for me to pick up all of this rice with just the single chopstick instead of 2. All right, so if you have followed along with me and you've poured rice into your bottle and you've packed it in there tight enough, here's what you can do. I'm going to take this container and I'm going to take my chopstick and I'm going to force it down into the rice. Now, 1 chopstick in all of this rice. Will I be able to pick up the rice with that single chopstick? Let's find out. Check it out. Check it out. All righty. Why did that happen? What do you think? Why is it possible for me to just put a stick inside of an open bottle that has rice in it and pick up all of that container and the rice? Okay, why in the world is that happening? How does that happen? Did you write down your hypothesis? All right, here's your answer. Well, when you take that stick and force it into the rice, each little kernel of rice has, or grain of rice has, is contributing a small amount of friction, a little bit of friction. Remember, friction is the one object is resisting the motion of another object, okay? And that's how you're building this up. Well, if that's the case, each grain of rice has its own little bit of friction that is building up. But imagine inside of this container, there are thousands of grains of rice, and imagine that the chopstick is actually touching hundreds, perhaps, maybe even thousands, but let's say hundreds of grains of rice. Well, if I take hundreds of grains of rice and each of them are contributing just a little bit of friction, after a while, that little bit builds up and becomes a large amount of friction. So as I forced the chopstick down, it was being resisted on the way down, but on the way up, now it's equally being resisted. And so I can actually lift up this entire container with just 1 chopstick because so much friction has been built up along the surface of the chopstick with each grain of rice. And that is how I'm able to pick up the entire bottle and rice. Now, I will tell you, this was made a little bit easier. It's actually not very easy to pull this out. Oh boy. Ooh, isn't it strong? This is not a game. I'm serious. Oh my goodness, I don't know if I can get this out. You know what's gonna happen? I've had this happen before. I am pulling this out and it is stuck. It is actually stuck in here. And I've done this before where it's been stuck like this. And then you know what happens? When I actually pull it out, all the rice goes everywhere. So if that happens, please do not make fun of me. Don't laugh too hard. Oh my goodness, I actually can't get this out of here. Okay, only a little bit of rice spilled. That gives you an idea. Remember I said you build up a little bit of friction in a lot of areas and it actually becomes really strong? That hadn't happened to me all day. I tried this a few times today and that hadn't happened all day. But yeah, it was really strong that time, okay? So friction can be very strong. I was going to mention that this chopstick, if you can see it, it is wooden and it's smooth, but it has some ridges in it. So there is some roughening on the surface. And because of that roughening, it is easier for friction to build up. In the same way, it's easier for you to build up friction on a concrete surface than on ice, all right? Because the ice tends to be smoother. Well, with that in mind, here is what we call a glass stirring rod. And as a chemist, this is something that's very familiar to us. We take these glass stirring rods and we use them obviously to stir mixtures of fluids. Okay. So it is smooth. It's made of glass. That's in contrast with the chopstick, which was not as smooth and made of wood. Okay. Last question for today, or at least for the experimental portion. If I take this glass stirring rod and put it in this bottle with this rice and force it down into the rice, is it possible for me to lift this entire bottle of rice in the same way that I lifted it with the chopstick? What do you think? Make sure to write down your hypothesis. Write down your hypothesis, all right? Here we go. Give us a try. Oh boy. All right. Try my hands. Are you excited? Are you excited? Here we go. Check it out. Check it out. It works just like with the chopstick. So what does that tell you? Okay. One thing I haven't really emphasized in all of our discussions is the post-experimental analysis. So after I've done my experiment, well, let's say at the beginning, I have a question, and based on that question, I write down my hypothesis. I know my protocol for my experiment, and I execute my experiment. Okay. Then I write down the results. My hypothesis was correct. My hypothesis was incorrect. But then there's this other aspect of science where we have to analyze. We analyze a few things in certain aspects. So what was different from the first time I did this to the second time? The first time I used a wooden chopstick that had ridges on it, so the surface was not perfectly smooth. The second time I used a glass stirring rod with a smooth surface on it. Okay, very smooth surface. So the materials are different. Their surface roughness is different. All right. Oh, I see my niece and nephews. Y'all can't do it? It's Tony and Laurelyn and James. I see y'all. Just practice. If you can't get this to work, what you need to do is really if you can find a bottle, it makes it easier. You can do it in a cup, but if you find a bottle, it'll be easier because you really want the forces of you want the rice packed in there fairly tight. And then you want to force down your chopstick or your glass stirring rod. This will work with pencils, but you got to get them in there pretty good. All right. And once you force it down there, you'll know it's going to work because you can see it resisting as you're pushing the rod or the chopstick down, and it should work. All right. So I hope it works for you. If not, Uncle Daryl can show you later on. All righty. But after I've done my experiment, now I'm doing some analysis here, and I'm saying to myself, well, in the first instance, the surface was rough. So maybe I'm thinking with a smooth surface like a glass stirring rod, this won't work because it's smooth and the chopstick had the advantage of being wooden and rough. Well, now we know, having done the experiment, that it has that the smoothness of the surface may play a role, but we can still execute the same. We can still get the same result. Okay, which is we can pick up the container with just the stirring rod, the smooth glass stirring rod, in the same fashion that we picked up the container with the rough wooden chopstick. Now, I'm guessing that it won't be as difficult to pull the stirring rod out because it is smooth. And so I wouldn't expect the amount of friction force to be as great as with the wooden chopstick. Let's find out. Try my hands again. Okay. Much easier to do that. All right. Now, if I were to make another experiment out of this, maybe I would do that 10 times. Try to force that glass rod in there as hard as possible and see if it's easier all 10 times to actually pull it out. And that would be a qualitative analysis. A quantitative analysis would require me to have some kind of instrumentation that measures the amount of force being used. All right? Everybody's at home. Most of us don't have that kind of equipment at home, including Dr. Boyd. But qualitatively, I could be able to say, well, it was much easier to pull the glass stirring rod out than the wooden chopstick. And therefore, I could conclude, at least qualitatively, that although both allow me to lift up the entire bottle of rice, it is easier to remove the glass stirring rod from the rice than the wooden chopstick. And that is likely because the glass stirring rod has a much smoother surface. All right. So this is how a scientist look, or at least one way a scientist looks at an experiment. All right. So again, why did this happen? Each little grain of rice has contributed a friction force that is now being applied to either the glass stirring rod or the wooden chopstick. Okay. As a result of all those little forces aggregating or combining their forces together, it prevents the chopstick or the glass stirring rod from coming out of the rice easily. And therefore, it's possible to actually lift the entire container. So let's go back to our original question. Is it possible to pick up all this rice with just one chopstick instead of two? Your answer is yes, it is. All right, I hope you enjoyed that. If you're not able to get it to work, you can go to my YouTube channel. I have instructions on how to make it. Again, you can find me on YouTube at Dr. Boyd the Chemist and look up friction rice. I have a video where I explain the physics and the science behind this demonstration, and you can follow along and give step-by-step instructions on how to do it in case you weren't able to get all of it today. Tomorrow, we will be doing an experiment we call ice on a string. And what you will need for tomorrow is a cube of ice, you'll need some table salt, and you'll need a piece of string, maybe about 6 inches long. And yarn works, the kind of string that I used yesterday to make the paper cup telephones, that will work also. And so that's what we're doing tomorrow. I hope you enjoyed the lesson today, and I will see you later. Take care.